All right, so I'll let you pause the video and read the context if you haven't read it already. But this is number 14. We're going to take a look at. We're actually going to go through the full-blown thing. If you don't want to watch it, no big deal. But the question only asks you to state appropriate hypotheses. Just to give you a little more practice, we'll go through the full-blown state plan, do conclude, and actually run our test and make a decision. So first thing we want to do is we want to state. And under the state, we want to make sure that we include the alpha level. We put into context what we're running a test for, and null hypotheses, a null hypothesis, alternative hypothesis, and also defining any kind of notational things that we introduce. So real quick, just piece by piece, this is what it looks like. So the first thing is put into context what you're about to do. So that looks like this. So first part, we're going to conduct a hypothesis test at the alpha equal 0.10 level. They didn't give us an alpha level, so I picked 0.10. You could also do 0.05 or 0.99, something like this. When it's not crazy critical that we're deadly accurate, usually a alpha equal 0.10 level is okay. And then put into context what we're looking for. So we're looking for a difference in the proportions of freshmen and seniors who've used steroids. Second thing are the hypotheses. The null hypothesis looks like this: P sub F minus P sub S equals 0, or in other words, in layman's terms, there is no difference between the proportion of freshmen and the proportion of seniors um, that use steroids. And there's more specifics, but that's the gist. There's more specifics of the context. They have to be Illinois high school freshmen and seniors who've used steroids, but that's the gist. The alternative hypothesis looks like this. And that effectively states that there is a difference in those proportions. And more specifically, this is going to be a two-tailed test. A two-tailed test. So we want to specify that somewhere. I didn't specify it in that state up above. So I'll make sure that I specify that down in that do section. But either way, these are our null and alternative hypotheses. We've introduced a little bit of notation, P sub F and P sub S. So we want to make sure that we define what that is. So we make a statement like this. And then I'll do it for our state portion of this. So next we move on to the plan portion. Under the plan portion, we're going to check conditions. So we've got three conditions, and here are your three conditions. All right, first condition, we've got random. We need both samples to be pulled randomly. And up here it says that they surveyed random samples of 1,679 freshmen, 1,366 seniors in Illinois. So both surveyed randomly. So we're good there. Less than 10%. We have to assume, we don't know a lot about Illinois students, but we have to assume that both of these 1679 freshmen and 1366 seniors are less than 10% of the population. So if we assume that that works, we're good to go there with our second condition. And then our third condition, n times p and n times q both have to be greater than or equal to 10. So in other words, we have to have more than 10 successes and 10 failures for each one of these. I'll show the quick math, but essentially these check out. So in this case, because they give us raw data, they don't give us actual proportions. We're not going to be checking n times p. We're just going to be noting that there are 34 successes for freshmen, and I put successes in quotes because that means you use steroids. And there are 1,645 failures, both greater than 10 there. 24 quote unquote successes, people that use steroids here, and 1,342 failures. So that one checks out. We can use the normal model for our sampling distribution and therefore run our test. So next for us to do is the do portion where we actually run the test. Before we run the test, we want to A, specify what test it is. So this is a 2 proportion z-test because we're dealing with proportions. And because we didn't specify up here in the state section, we want to specify whether it's one-tailed or two-tailed. According to our alternative hypothesis, this is going to be a two-tailed test. So we'll make note of that. And then under the do section, we're going to use our calculator, but there are two things that we want to make sure that we include. So the two things first are p hat, or the differences in our proportions, and also we want to find our z. So we'll go through the calculations on those. First, let's start with p hat. And in this case, because because we're dealing with proportions and we're running a hypothesis test and assuming that there is no difference between the proportions, we're going to be calculating a pooled p hat. So in order to calculate that, I'm going to set up the pooled computation here. I'll show you what that is. It looks like this. So just real quick, we're going to take our number of successes in the first sample of freshmen, add that to our number of successes to get in the seniors to get a total number of successes. So we got 58 total successes. We take the sample size for the freshmen, the sample size for the seniors, combine them to form our denominator. So we get 3,045 when we combine the two samples for a total pooled proportion of 1.9% or 0.019. Next thing we want to do is calculate our z-score here. So to calculate the z-score, we're going to take the differences between the two proportions. So there's the differences between the sample proportions calculated. This one is just 34 over 1679. This is 24 over 1366. We subtract the quote-unquote true population difference in proportions, which we're assuming under that null hypothesis is 0. And then the denominator looks like this. So we've got, this is where that pooled proportion comes in. So our pooled proportion is 0.019. Here's the complement of that divided by the sample size for the first sample, and then pooled proportion times the complement divided by the sample size for the second sample. And this should all simplify to a z-score of about 0.54. So hopefully you recognize that that's not a very large z-score, not very high z-score. So you should have an idea of what your test is going to come out to be at this point. But let's go ahead and run the test anyway. So we're going to go to our Inspire software here. I'm going to hit Menu, Statistics, Stat Tests, and this is a 2 proportion Z test. And we got a bunch of information that we want to enter. So that information, I'll go ahead and enter that. So here's our relevant information. We got 34 successes for the freshmen, 24 successes for the seniors, 679 sample freshmen, 1366 in the sample for seniors, and this is a two-tailed test. So let's go ahead and run this, and there's our information. So we got our z-score matches with what we see here. Here's the important thing from the test. That's our p-value. Pretty high p-value there, 0.59 or 59% chance that we get that result due to natural sampling variability. And then again, our pooled proportion is right there. So we've run our test. Our p-value when we ran our test is equal to, I believe it was 0.59, really high for that one. And now we can jump down to the conclusion. First thing we're going to do on our conclusion is we're going to take our p-value, compare it to the alpha level, and make a decision about our null hypothesis. So this is what that looks like. So we got our p-value here, 0.59, and our decision about H naught based on that p-value and a comparison with the alpha level of significance. So the next thing we want to do is just provide context or provide an idea of what that decision means within the context of the problem. So that looks like this. So we conclude that there is not evidence of a statistically significant difference between the proportions of freshmen and seniors in Illinois that use steroids.